All right, thank you very much for yet another class. This is Introduction to Networking. Networking is a very, very fundamental concept when we want to talk about DevOps and cloud engineering in general. So we want to talk about some of the key concepts that we cannot ignore, when that forms like a basics, for the understanding of cloud engineering. So, yeah, so let's dive in. Let's dive in. So there are a few people in the class today. I don't know why, but yeah, let's continue. So first of all, what is networking? Networking refers to the practice of designing, implementing, managing the communication infrastructure that connects various parts of an application, such as servers, databases, containers, and cloud services. It ensures seamless data exchange, security, and high availability within and across environment. Yeah. There are networking models. Networking models defines how data is transmitted and managed across computer networks. They help standardize communication, ensuring ensuring different systems can interact efficiently. The two most widely used models are the OCI model and the TCP/IP model. But there are other models used several contexts. So for the sake of this class, we're only going to be looking at the TCP model and the OSI model. So now, this is the OSI model. You can see that there are 7 layers of this OSI model that we're going to look at basically. So the first layer is the physical layer. So the physical layer is one of the most important layers in this setup because it refers to the external part of the networking, the networking system, like the raw hardware and the electrical signal. So when you want to talk about networking in general using the OSI model, the physical layer talks about the raw hardware that is being used. When you talk of cables, talk of switches, talk of routers, and all those setups, basically. That's what the physical layer is all about. So when someone is talking about this cable, they ask you, the Ethernet cable is part of this layer. So it's like a framework. This OSI model is basically like a framework that guides you to identify stuff in terms of networking. So you have the cables, you have your switches, you have your routers, you have your hubs, and all those networking, those networking devices. You can go and read more about those stuff. All those networking cables, switches, and the rest deals with the raw hardware and the electrical signals in a networking system. Then we talk about the data link layer. The data link layer is also another fundamental concept in the OSI model that's please confirm you can hear me.
You can hear you loud and clear, sir.
Okay, so the data link layer is also a fundamental concept in the OSI model that deals with data transfer These are deals with point-to-point confirmation, deals with, so if you want to talk about the network, you talk about how data is transferred from one point to another. You attribute that to the data link layer. Then there is the network layer, which deals with logical addressing, and the physical part the data will take to, to move from one point to another, which is the IP address. You attribute that IP address, you attribute that to yeah, basically IPs, and just generally talking about the path that the data will take to move from one point to another. Then there's a transport layer. Transport layer talks about reliable or unreliable delivery. So there is the TCP, which is the Transmission Control Protocol, and the UDP, which is the Unified Datagram Protocol. We will discuss more about that later. Then there is the session layer. Session layer maintains connections and is responsible for controlling ports and sessions. So in systems where you deal with a lot of, logging in and logging out and all those setups, that require you setting up sessions and terminating sessions, that is what the session layer does. It is like, so this concept now, basically, let me go back. This concept now is basically fictional. It's like a framework, not something that you come and say, oh, this you come and put your head and be like, oh, this is how it's in this. I don't know which English I will put, but it's like a framework basically to help you understand what part of your networking setup belongs to a part. So now there's now the presentation layer to ensure that the data, so that data now, ensuring that the point where the data is usable, it's in a usable format, is what they call the presentation layer. So you have the SSL, the JPEG, those are your JPEG images, that like an output of a transfer is the presentation layer. So for example, when you transfer file from one medium to another, the output, which is the okay, when you transfer a picture from one medium to another, the output, which is the picture, is the presentation layer. Then the process of being transferred is the combination of the session layer, transport layer, and the network layer. I don't know if you understand me. Then the setup that facilitates those transfer is what makes the physical layer and data link layer. I don't know if the concept it's very, 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 very shaky. That's something that it's a theoretical concept. So that's why it's not something that, oh, you come and do hands-on or come and do practice. No, it's a theoretical concept that you understand. So take for example, you're trying to, and then there's the application layer. So there's the network services that directly interact, the human computer interaction layer, where the application can access the network services. So you have your HTTP, you have your, yeah, the HTTP basically. So let me go, I feel like I should go back to explaining. Actually, let me go back to explaining this. Now let's start from the physical layer. So the physical layer, like I said, is the first layer of the whole system. Now let's start with the physical layer is the first point. So layer one, physical layer. It is the layer that deals with the raw transmission of data. So your that's your that concept that you want to, that thing that transfers data basically is like the wire. It's like the wiring. So that's that whole networking concept that transfers data is what we add, is what you attribute to the physical layer. You get, and part of the physical layer are like the cables, your pins, your hubs, all those Ethernet cable, fiber optics, wireless that is used to transfer data. That is what you attribute to the physical layer of your networking OSI model. Then the data link layer is the communication. So that communication that, so when there's a wire, which is the physical layer, connecting point A to point B, the communication that ensures that point A is connected to point, because you can run like a wire from point A to point B, but the connection may not necessarily exist except you activate, you do what you call your MAC addressing, your, just the general setup. So that communication that is present to ensure that the medium A and medium B are connected is attributed to the data link layer. It's called the data link layer. I don't know if it's clear enough. Then there's the network layer. So the network layer is what handles routing and addressing and decides the path which the data will take. So for example, now there's a connection. You have to like label the different, you have to label the different, the end to end, you have to label it. So most this label is usually attributed to what they call IP addressing. So that label, that ability to that ability to get that label attributed to that component that is being connected to is attributed to the network layer. I don't know if it's clear. These devices now that do all those stuff is the routers, and yeah, to ensure that the data knows exactly what to reach based on that label that is the IP that is given to that system. Or basically, that's attribute that to the network layer. Then there's the transport layer. Transport layer is like the logistics manager, basically, ensure this, what transport layer does is basically just ensuring that the data goes in the right order, that data that is meant to a particular point, sent to a particular point, reaches that particular point, and it displays. That's basically what the transport layer does, basically. So there are two types of protocols that are used in transport layer: the TCP protocol and the UDP protocol. TCP protocol is more reliable and is used for all this web browsing, emails, and the rest, while the UDP protocol is mostly used for video streaming, all those systems that have a lot of data consumption, but you need it to be as reliable as possible. That's why you use UDP. Then the next one is a session layer. Session layer manages conversations between devices. So that's let's just use a phone call now as an example. So when you make a call, that session layer is what basically ensures that you are still online. So let's just use another example, a login logout system. A login logout system. When you log in, it creates a session. So that session now is what ensures that it is your identity, which is your IP address, or your computer address, that is mapped to that session. So when you log out, it terminates that session. So that's what the session layer does. That's what you attribute to the session layer. Then there's a presentation layer. Presentation layer is what translates is the translation of data to something that we can see, basically. Something that is readable, that is usable. So what embodies a translation, a presentation layer is when we have files like JPEG, MP4, just basically all those data types, basically. Then application layer. Application layer is the user interfacing layer, which is, it can be your browser, it can be your email, file transfer, basically. So this whole concept basically just explain. It's not something that you literally use to do anything, for example, but it's something that is like a fundamental concept that you have to just know, basically. So sometimes when you be like, oh, this file, this system, let's say you have an error in your data transfer, you have an error, you're trying to build something that sends an email, but it does not work. What will you do? You can understand where the problem is coming from, and then you know where to fix it. So let's take an example. And someone wants to ask, please, can you unmute your mic? Thank you. Okay, now let's do this. So let's take a very, very quick example now. Let us take an example of an OSI model, just a very, very quick example. It may be very, very difficult to understand initially. Like I said, this is a beginner class. But when we go back and watch the video and get to understand, it's a conceptual thing. It's not something that I'll tell you, oh, you need to watch my screen to perform anything. No, it's a very, very conceptual stuff. Now, let's start from the application. Let's run this. Let's start from the application layer. Now, in as much as the physical layer is the first layer, the data movement actually starts from here, basically. Start from the application layer. So let's use example now, the client or you want to access a site. Let's say you want to access google.com or whatever site. Once you put google.com on your browser, the first thing that it does is to make a HTTP request. So the HTTP request is a request that is made immediately. It's made immediately from it's made immediately. Please, can you mute your mic, please? Thank you. Elijah, please mute your mic. So once you do the example.com or google.com or whatever, elijah.com, it creates a request. So that request is what is the HTTP request. And it's called HTTP Hypertext Transfer Protocol. So it's like you sending your houseboy to go and get something. Your houseboy is basically like the HTTP request you get. Now, your houseboy goes, and then the presentation layer encrypts the presentation layer. The presentation layer is what's in charge of encryption. So I was trying to explain this in the best way. So once your request is made, it will check whether that request is secure, which is, having SSL, having like an SSL, covering, like just ensuring that the request is secure. So that's what the presentation layer does. Ensuring that, oh, this request that it has just been sent is basically like secure. If it's secure, it now creates a session within the server. Now this session now is like it's this session basically, it creates a session. So it creates like an identity, like a footprint, basically. Let me use the word like that. Let me use that way. It creates a footprint to mark that, oh, this social request has been made. That's what the session layer does, basically. Then the browser creates the browser establishes that session with the server to ensure that, oh, okay, oh, someone has I've sent XYZ person that is wearing a red shirt to you. So that session is what identifies that a request has been made to this server coming from your browser. Then it's then the transport layer. What the transport layer does basically is assigning port number. So for every application that is deployed to a server, there's usually like a port number attached to that application that is used to run the application on that server. So once your session goes in, it identifies the port. That's what the transport layer does. It identifies the port where the application is running and then picks it up. And so it's like, I always use layer as an example. It's like going to, there are 4 markets in a place. You know that market one will sell whatever you want to buy. So you send your boy to, you must go to market one to get this. Or your boy, even if you don't specify, your boy knows that, okay, market one is where this thing is most likely to be found. So it goes there straight. Then network layer, on the other hand, now is now the address that is assigned to, is now the address that's assigned to that destination. Yeah, it's now the address assigned to that destination. So basically like an IP address. So it's the network layer is what's in charge of. Network layer is basically what's in charge of, as packaging your boy or packaging your request into like an IP to map it to the destination, basically. Then the data link layer is what now creates the connection between your request and the destination where that request is going to. Then the physical layer is the medium, which is if you are sending that request or that browser, since we're using a browser, basically we're using Wi-Fi or you're using the internet to Wi-Fi. So that your Wi-Fi now is the physical layer that is sending that your request. Now, once your request has gone and has reached the destination, there's also another response. So there's like a response coming. There's a like response coming back. So there's a request response. That's why when you put a particular site and you press enter, the site shows immediately. All these entire steps that I've just listed out, in a split second, it happens. Now, there's a response coming back. That response, it gets to the destination, picks what it wants to pick, which is the information that you're asking for. It now sends it back to the physical medium, which is through the Wi-Fi and everything, goes back to the data layer, adds an address to that particular response. It now picks the IP address of the where you picked it from and maps your own laptop IP address as a destination coming back. And it just goes through that whole process. When it gets to the presentation layer, it now also checks if it's encrypted. So it still runs that whole setup to ensure that, oh, that particular place where you're accessing the data is, it's encrypted. And then you will see the website rendering on your browser. I don't know if this makes sense because I'm trying my very best to break this down in the most fundamental way so everybody will understand. So this is what this is what the whole concept is. Like I said, it's a theoretical concept. So it's something that you need to understand, basically. But over time, yeah, like I said, over time, this concept has been there right from time. It's like I said, it's a theoretical concept. Over time, based on the complexity of this whole concept, you get, based on the complexity of this whole concept, it's been difficult, to be able to, for people to, just the way I'm explaining it now, it's been difficult to manage. And, as things are getting, the internet is becoming, more open and everything. So there has been the creation of like a new concept, which is the TCP/IP model. TCP/IP model. So the TCP/IP model is a more modern concept of networking. That you don't even need to wrap your head around the OSI model, in as much as the OSI model is still important to know. But in all honesty, the current internet, basically, the current networks set up gravitates more towards the TCP/IP model than the OSI model. So what is TCP/IP model? It's also an internet protocol suite that also, describes how data is transmitted over network, especially the internet. Now that we have the internet has become, widely adoptable. So most people gravitate towards the TCP/IP model better than the OSI model because of the complexity that the OSI framework brings. So now, what is the now TCP? Let's start with the application layer. Now this one has only 4 layers. Unlike TCP, unlike the OSI model that has 7. Like the OSI model has 7. This one has like 4 layers. The application layer, this is the layer that interacts with the software to send or receive data. That software can be your browser or your, just basically stuff that sends requests and receives response, basically. Now, when you send requests from a browser, it goes over to the transport layer, and this transport layer enables fast delivery of data, support communication between diverse devices across diverse networks. So now, the transport layer encapsulates the network session. No, the application layer encapsulates the application and presentation layer. Then the transport layer encapsulates the session and transport layer from the OSI model. The internet layer, which is a layer that, the internet layer in this case is a layer that the internet layer is a layer that handles addressing of and routing of data. So that whole packaging, when you send the data, it addresses your data just like a post office setup, basically. Once you send a request, it packages your request and delivers to the right source. It's handled in the internet layer. Now, this internet layer encompasses the session, transport, and network layer in the OSI model. It's a more simplified, framework that encompasses those session, transport, and network layer. Then there's the network access layer, which controls the hardware and the physical devices that makes up the network. So this network access layer now encompasses the physical and data link layer in OSI model. So you can see this one is a bit easier to understand. Much as it still they're all conceptual concepts. They're all theoretical concepts rather, but this one is easier to understand. Basic, and this is what is used in practice correctly. The reason why I introduced the OSI layer because that one is still the fundamental concept. But if you are designing networks, especially in a cloud environment, you're designing network infrastructure. The TCP/IP model is what you would need most likely to be able to, properly put each network component together. Let's get like a real world analogy, yeah. Application layer. Let us use, like I said, let us use a post office setup now. Application layer involves writing the letter. Now, you write the letter and you send it to the post office. This is where your web browser, let's just now go back. Your web browser prepares a HTTP request, which is like a request, for a particular, server or for a particular information over the internet. That's writing a letter. Then the transport layer in the post office setting divides your letter into envelopes. So for example, if you're used to the post office setting, you will see that when a particular letter is going to, let's say, from Port Harcourt to Lagos, Port Harcourt to Abuja, the particular, I don't know how it works, but it's a particular set of letters that they will put aside that will go to Lagos. Particular set of letters that will put aside that will go to Abuja. You get to ensure that everything is properly aligned. In this case, that is what the transport layer does. What transport layer does is to break your data into segments to ensure that it reaches the right destination, because there are billions of devices, and each over the internet, and each device is connected. Each device has an IP address that is connected, that is used to label that device. So once you send your request will go and look for the billions of systems all around the world that has the same IP address that you are looking for. It will first of all get your system's IP address as the source, and then it now looks for the IP address as a destination. Then that's what the internet layer does. It's takes your IP address. Each device, each laptop, each phone, each device has its own IP address. So it will go and now look for. It will use your IP address. So your IP address is like your laptop identity, like your laptop's name. Basically, you're going to look for a destination, which is that other device that's holding that information that you're looking for. That's the destination IP. And then when it gets it, it now picks it up and then returns back to you. So it's like a request response system. You get, it's like a request. So this thing happened in like a very split second. Just try looking www.something.com. That split second where your setup comes on, where your browser comes on with the site, this is all the stuff that happens in that split second. Now, you will see some certain situations where you want to try and reach a site, and then the site, they will tell you cannot reach the site. Now, what they will do is that the people that actually, when your laptop, as I said, your laptop has an IP address. So when your laptop IP address is also mapped to what they call a geolocation. So you being, for example, you are in Nigeria, your laptop address will show anybody around the world that this device is in a region in Africa, just basically that stuff. So for a situation where most people, now what they will do is that they have their systems, they've already created their systems, the IP address, but they don't want IP addresses from a particular region, which is like Africa, most likely, to access the information that is on that IP, that is under their server. They will now like restrict the geolocation. That's why when this whole request is made, yeah, once a laptop goes, once a request goes from your browser create with an HTTP request, and it will take your laptop IP and then now goes and runs a search on all the billions of servers around to find the one that has the information through what they call DNS propagation, which I will explain that one. So what they call DNS propagation. Once it picks the IP, it will pick the IP. The geolocation block will now tell your IP address that this computer that is in Africa is not allowed to access the information that we have. So it will go back to you and tell you you cannot access this site from your read. That's why you will see some sites that you want to access, you cannot access it. Now, what some people now do is using what they call VPN. I'm sure most of you are aware of what VPN does. Now, the VPN, it covers up your laptop IP address or your phone's IP address. And you can, so VPN servers are foreign servers that create like a link from your device to those servers. So once you turn on your VPN, it will max your phone or your laptop's IP address to use the IP address of those servers that were created with the VPN. You get? So once you send a request, instead of the request leaving your browser with your IP address, it leaves your browser with the IP address of those servers, which are used most likely in the US or in Europe or something. So when you hit that particular server that you are going to reach, it will look and be like, oh, this IP address is coming from the US, basically, and then now gives you the response and gives you back onto it. That's why you see when you turn on a VPN on some sites, you will see some information that you won't normally access when you're not using VPN. That's how the whole networking, that's how the whole stuff works. Now, like I said, there's what they call DNS propagation. Now, for every server or for every system, they have what they call an IP address. Now, this IP address is usually mapped to a domain name. Which is very mapped to a domain name. Now, that's why it is not convenient. How will you feel if you're in a system where, you want to probably type Facebook? Instead of typing facebook.com, you go and type /192.16, all those complex numbers. You go and type all those ones. It doesn't make sense. It will be difficult for you to access the internet from there. That's why the concept of DNS came inside. So what DNS does is that DNS will attach a unique name, which is your URL, which is the www.xyz.com, to your IP address. So once it attaches it to an IP address, once a request is sent, which is put that that domain name on the browser, it abstracts the IP address. It is the IP address that is on that domain name that will serve as the destination IP. So what your internet and your network will do is it will take your laptop IP and then take the IP address from the domain name that it has abstracted. That's what it will now use on its search and then run all the billions of search to find which exact server hosts which exact server has this IP address that I need this information from, and then gets it and brings it back to you, basically. Do you understand? Please understand, I beg. Thank you. Please give me feedback. Do you understand the concept? I know that this is a new concept, but do you get where I'm going to with it? Please, I need feedback. Hello, I can't see the chat, so those who are chatting, please, can you unmute your mic now and just say something?
Yes, sir. Small, sir. Small.
We understand. We are
Small. Hey, good. Okay, so like I said, it's a very, very theoretical concept, but it's something you can go on it. You can go for interviews and they ask you, okay, what happens when you click www.this in a computer? You have to explain it in the simplest of terms. So, like I said, an IP ad your IP address is so all these things is within this layer now, this TCP/IP layer. So your IP address, this application layer is where you put in the IP address. You get, you put in the domain name. So when you put in domain name, once you send, it's the transport layer now is now what is responsible for getting that IP address that's attached to that domain name. You understand? It's getting that IP address that's attached to that domain name and setting it as a destination. So it's like a journey. That's what the transport layer does. It to get the IP address. All servers are most servers are mapped with domain names, either internally or externally. The one that you mostly access is for external use. They're ones that you cannot reach, basically, just within like a company or something. But yeah, once you access it, the transport layer is what is responsible of getting the IP address that is attached to this setup, attached to this domain name. Yeah. Okay. Sorry for the breaking transmission. So yeah, so the transport layer is what um the transport layer is what go abstract the IP address and set it as a destination. Now the internet layer is now what ensures that your request goes to that particular destination from your source, which is your laptop. And then the network access layer reaches the destination. If it's not blocked by VPN, picks it up and then returns it back to your browser. So this thing happens in like a split second, like microsecond safe. This is just what happens, basically. So yeah, let's move forward. Let's move forward. My throat is dry with this explanation. Now,
That water.
Karen, are you saying anything?
You said your throat is dry. I said you try and drink water.
Oh yeah, 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 I have water. Don't mind me. So, now these are some concepts that you will get to hear a lot while we move. These are concepts that you will get to hear a lot. So that's why I'm trying to like bring it out here so that, when we start talking about IP addressing, you will not get to be confused. First things first, core networking. There's IP addressing. Like I said, IP address is like a unique identifier that is assigned to a particular device in a network. Your phone has an IP, your phone has its own IP address, your laptop has its own IP address, or your computer has its own IP address. So for as far as you are working with a device, that device has an IP. It's like a label, basically. It's like a label that is particularly given to a particular device, for identification, unique identifier, like I said. There are two types of IP addresses, which we don't want to go deep into that. There's IPv4 address and there's the IPv6 address. The IPv4 are the a lot of companies, use the IPv4, but a few more companies that are coming up, especially in modern days, they tend to switch towards the IPv6 model. If you are more curious about that, you can learn about it. Then there's the subnetting. Now, when we go into AWS cloud networking, we understand this concept better. But subnetting is I have a large network, or I have a large network, basically. I want to break this network down into sub networks that can easily easily used to work with. For example, you have a large network that can accommodate like 1,000 people. You now want to break it down into sub networks within that network. That's what subnet is all about. You can when we get to the point where we design, because we're not doing for this class, we're not doing like core networking. We're only going to do cloud networking. So when we go into that, you would get to understand the whole concept. But I'm not trying to explain, I'm not trying to give you like a theory. Then dividing a network into smaller manageable segments. Then it's a CIDR notation. Does that has the IP address? So once you can have a large network. You can have a large network and then you'll be asked to like break them down into, so you can do your setup in one particular section, then you do another setup in another particular section instead of using the entire network, basically. So CIDR means like classless interdomain routing. So yeah, it's a routing system, basically. There's the VPC, which is the virtual private cloud. So it's the isolated virtual network in the cloud. So when we are doing cloud networking, we will talk about the VPC and creating a VPC network. So yeah, when you want to deploy your server, you want to deploy your system, you have to create it within a network that's, it's like an encapsulation, just like building a house or building a system where your servers would be stored so that most likely for security, or what they call high availability, or what they call fault tolerance, which is a system where that VPC will encapsulate the system for prevent from hackers and all those stuff. So there's AWS VPC, there's GCP VPC, there's a public and private IP. Now, within your network, when you are building networks, basically, there are some IP addresses that are only useful for resource-to-resource communication, which is private IP. Now, you can set a private IP. Now, that's why it's not all the servers that people can access on the internet, because a private IP is an IP, like it's an IP. I already explained what an IP is. So a private IP is an IP that I only set it so that other resources within the network can work with each other, not because I want someone to be able to access the server. So for example, I set a private IP on my server on server A, because I want to work with server A on server B. So that communication between server A and server B is going to be facilitated by the private IP. And the internet, which is your public domain, your public access, cannot come into the server because there's no public. So what makes a server accessible to the public is the presence of a public IP. So this whole setup that I just explained to you in the TCP/IP model, that when you send your request to map, so that IP address that is mapped to a domain name is a public IP address. You get private IP address cannot be mapped to a domain because it's not something that you can access from the internet. You cannot map it to a domain name. So yeah. So that's the difference between private. So private IP address is only used for resource-to-resource communication. For example, you have a server that wants to interact with a database, or you have a database that wants to interact with the server. That's when you now use private IPs to do that interaction. Sometimes most people decide to use public IPs, which is their own concern. But to be on the safe side, the private IPs are the better option, because to prevent internet access. You understand? To prevent the public from getting. I know that some people will say, oh, they can configure firewalls and the rest, but it's just best to not to use a public IP for a sensitive server. Yeah. Then domain name system. Domain name system, like I explained to you earlier, I've already explained some of these things. Converts domain names to IP addresses. So when you like work with a server, your server hosts an application, you now have a public IP. You now map that public IP to a domain name. So instead of someone to go to your site and type 192.168.0.1, they just type the domain name, and it will do that translation on your browser. It will find the domain name that is attached, the IP address attached to the domain name, and then do all those work for you. DHCP automatically assigns IP addresses to devices. Yeah, then there's network access translation. Network access translation allows multiple devices with private IP to use a single public IP. So for example, if you have a device that you don't want, now let me explain this one now. If you have a device that does not have a public IP, but you want to download resources from the internet into that device, probably you want to download a package, that thing you did in your test, sudo apt install kini, you have to use a NAT. So it is that NAT now that we create a it will create a public IP, but it's not attached to the server. It is like for rent, basically. It is basically like for rent. So once you attach this network access translation into that server that has no private IP, you can now get resources from the internet. Probably you want to download updates or you want to download packages, which is what we did in last class. Sudo apt install XYZ, all those ones. It is the presence of a NAT that will do that whole work for you if you're working with a server with no private IP that has no access to the internet on its own. So a NAT now creates that public IP that you can use. So once you destroy the NAT, it destroys that public IP setup, but your server is still there. So yeah, in cloud environments, NATs are quite expensive to use, but we'll take a look at it when we're working. Then, yeah, NAT gateway AWS. Then routing. Routing determines how packets move from source to destination. Yeah, then firewall. Firewall is like it's a setup that helps to control the quality of traffic that comes to your system. So if you want a particular if you want traffic to a particular port, you use firewall. So all this concept we'll talk about them when we go deep into AWS. Now there is the load balancer. So a load balancer basically is a setup that helps you to, just like the name implies, balance load. It helps to distribute traffic amongst different servers. So in an ideal production setup, yeah, it's usually not advised to put all your sources or all your applications in one server. In a lot of cases, what some people do is they put it on 2-3 servers that they will not attach what they call a load balancer. Now, a load balancer is what will receive it has like a public, most of those balancers have like a public setup. So that's what will receive traffic. So instead of receiving traffic directly on the server, which people can do, but talking about like a production setup, instead of receiving traffic directly on the server, what people do is that they attach a load balancer to like 3 more servers. So if let me say 50 people are to access that application, and the application is distributed among 3 servers, load balancer will put 10 in server A, 15 in server B, and then the rest in server C. Instead of having a system where 50 will hit one server at the same time. So that load balancer distributes the load, evenly among the different servers so that, the application reliability is still high. Because Once there's a high traffic on one server, there's a good chance that server is going to go down. So that's what load balancer basically does in a networking setup. Now there's a reverse proxy. Reverse proxy handles client requests and forwards them to backend servers. Now, yeah. So, what a reverse proxy basically does is this. Once a reverse proxy is usually now for situations where you probably cannot afford a load balancer, most people now use what they call a reverse proxy. Reverse proxy also acts somewhat like a load balancer, but this one is that it can be attached to a server or multiple servers. It's the same concept here. Once the traffic does not hit the server, basically it does not hit the server directly. What it does is that it hits the load balancer, and it's the load balancer that will now forward the request to I said just say load balancer. It's a reverse proxy that will forward the request to the server, to the backend server. They to get the response, hit the reverse proxy again, and then send it back to the client. So basically, let me explain. Basically, a reverse proxy is like a receptionist. Basically, when you get into a place, you don't just go and see the CEO directly. You see the receptionist, and you state your intention, and then the receptionist now forwards your request to either the CEO or whoever you want to see in that setup. So that's basically what a reverse proxy is. Now, forward proxy also handles outbound requests from internal clients to internal clients. So it's basically like the opposite of a reverse proxy. Now, imagine just so like I said, the reverse proxy is like a receptionist. So when you come in from outside, you meet the receptionist, and then the receptionist now sends your request to whoever you want to see in the company. That's what a forward proxy is now. It's opposite. So forward proxy is that you are already in the company, which is the server in the company. You get. You now want to get some stuff from the internet, which is outside. You now probably meet this like a messenger. Most companies have like a messenger. You send your messenger. Messenger now goes to probably photocopy or do some other stuff for you, and then comes back into the company and reports to you. So this forward proxy, is not used as much. People mostly use it in setups where probably whatever they deployed on the server is probably banned or probably restricted from accessing some certain sites on the internet. So that's what now use a reverse proxy for, so that reverse proxy is what to like do that assessment and then give their setup feedbacks. But it's not it's mostly in complex systems that this whole stuff is used, basically. Yeah, so there's ingress and egress. So ingress in networking is called incoming traffic. Egress is usually referred to as what? Outgoing traffic. So traffic coming in from the internet to your server is ingress traffic. Now, requests going from your server to the internet is outbound traffic, which is egress. So I want to understand those concepts. Then there's the VPN. The VPN is, like I said, you connect to servers that, now there are two use cases of a VPN. I've already discussed one. If you want to access some certain sites that you cannot reach, is it even a second use case? It's also the same use case. So for example, now I want to connect to a site that they probably restricted my geolocation. I use a VPN, which is a public VPN, to access that site. You get to access that website. You use a public VPN to access that website. Now, same thing with an organization. If you notice, there are some sites that you are in an organization, there's some sensitive information that they don't want the public internet to be able to get. So what they will do is that they will create an internal VPN within themselves. I know this because I've done some for clients before. They'll create an internal VPN within themselves, for themselves as an organization. So once you go to a job in the company, you install that VPN in your laptop and you connect. Once you connect, there are some certain IP addresses now that you'll be able to reach with that VPN connected. So it's like a secure. This one is more on security. This second use case is more on security. You get protective, sensitive data. And it's very useful, especially when you're dealing with production databases. The one I set up for a client, was for a production database. He didn't want a situation where the database was public. We set up a VPN that every stakeholder, which is the developers that access the VPN, that use the database, must log in through the VPN. If you don't log into the VPN, even if you're typing the right database credentials, you will not still be able to log in. So that's what a VPN does, basically. Now, benefits of implementing networking in DevOps. Number one, scalability and high availability. Yeah, now, like I said, when you talk about stuff like load balancing, when you're building stuff as a DevOps engineer, you always want to focus on scalability, because you don't want to build something that traffic will come and hit it one day and it will go down. So that's why, like I said, in a production setup, you must ensure that your systems are scalable to a point where it can handle multiple loads when hit. You get. That's why people will mostly recommend the use of load balancers in their setup. So the concept around networking is to ensure that your systems are scalable. Number one. Security and compliance. Now, security and compliance is the bedrock of everything you want to build, basically. You don't want to build any system that is not secure, that, somebody can easily just press some buttons and the system goes down because of hack. You want to build a system that is completely scalable, completely secure, and compliant. Now, compliance simply means there are certain standards that a particular application should have. Is your application meeting that standard? That's basically what compliance basically is. So if you don't build an application, now that's what networking basically does, because it helps to ensure that, the security standard that your application gets, can get, so that, because people want to trust your application. People don't want to come to an application where their data is compromised, their sessions are compromised, their money is compromised. When you're dealing with stuff where you need to handle money, you have to ensure that implementing proper networking can safeguard against security and compliance issues. Yeah. So improved network performance and speed. That's just it, basically. When there's proper networking within your system, there will be improved performance in your application. You know that, this setup, your application does not the application does not go down easily. Your application does not lag. All those things are as a result of proper networking within the system. And speed, yeah. Speed also, yeah, ensures that, because there's what they call latency. When someone is trying to reach your application and it's taking time to load, all those things can be caused by network issues, and you won't want that. So implementing proper networking ensures that there's a good speed and performance. So, yeah, reliability and fault tolerance. Now, you can see this setup, this diagram set here. Whenever someone hit an application, you will see it's a load balancer. Now this load balancer will direct the traffic either to now these three data center A, B, and C, they run the same application. Most likely in a more broader setup, it's connected to one database or probably a primary database with a failover at this side, the same thing. But that's by the way. Now the load balancer here, once you hit this request to come and to give you the application here, it will give you the application here. Another person coming, most likely send the person to the application in C. But there's going to be a situation where, now this is what is reliability. This whole setup is reliability to ensure that too much load is not placed on one. So this load balancer will distribute, swing the traffic across these three. Swing the traffic across these three until, so that the traffic, the amount of load hitting the servers are balanced. But there's some situations where this whole setup will go down, probably for, I don't know what reason I can think of. Now, there's now a failover. So this failover now, you have to implement in such a way that it will be reading the application from this standby server while engineers are working to get this one up. That's what is called the failover. And this is what basically called fault tolerance and reliability. So this is reliability, this is fault tolerance. So when the application goes down, your application, proper networking will enable the application to be able to switch to this part while this one will be sorted out. Then when you sorted out, you can now switch back. And that's basically what setting up a good networking system is all about. Yeah. Thank you very much. So, does anybody have any question? Like I said, this is a theoretical concept. It's not something that we will start, trying to pull off VS Code and trying to build stuff. Does anyone have any question that can be addressed? Alphonsus, you can ask.
Good evening, sir.
Good evening.
So when you were talking about load balancing, you mentioned fault tolerance and so please can you just show the last slide before this again?
Okay.
Yeah, you mentioned fault tolerance and the load balancers. So my question is, for instance, once these load balancers are down and the fault tolerance is at work now, does it still gives you the complete information you are looking for?
Yes, no.
Or is it more or less like a custom 404 page you to be given?
No, it will not.
Okay.
It will not. That's why I said implementing proper networking. A proper network will show you it will show you, it won't even alert you. It's only when it's not properly, it's only in extreme cases that it will alert you, the user, that it is down. But some network that are set up, it won't even alert the user that the system is down. It will probably just be lagging or probably just be slower than usual or probably just some components will not work. But the system will still run. It's now the engineers that will now, because the engineers definitely receive alerts, that something is down. And then the engineers will receive alerts that something is down and then now work on fixing it. Because to be honest, not as much as we aim for reliability, you get some of these systems, not as much as they aim for 99% reliability, there's most likely going to be that 1% that'll happen. So you have to ensure that your networking is tight, basically. No loopholes anywhere because hackers are not sleeping. You understand? So first of all, I'm seeing networking tax next week. I don't think I'm setting any networking tax, except it's just basic. Like I said, this is a theoretical concept. So I'm not setting, I don't really find myself setting anything networking. I'm not setting any networking tax, so don't be afraid. I'm not setting anything. This is just a concept. So like I said, theoretical. Just learn to understand type of stuff. So is there any other question? I want feedback. Do you have anything you need me to, I won't say you need to talk about again because I said, but do you have anything that you probably want to figure out about this networking? Someone said, can we automate uploading? The uploading of the class is not in my hands. The uploading of the class is not on my hands. It's on the KodeCamp management. Once I'm done with my class, they are the ones that will fine-tune the videos and upload. So that's something we also need to. How does some sites know you are using a VPN? Even when you are using a paid VPN. Which sites know you're using? How does the site tell you you're using a VPN? Except when now there's some sites that are very, very advanced stuff. So if they see that probably like there's a network shift, a very, very quick, for example, now they see traffic, they are expecting traffic coming from a particular region, and then they now see all of a sudden that particular region, the IP address just switched to something in the US or UK. Some systems are designed to catch it and flag it as something that is, they're designed to flag it as something that is like a VPN stuff. But I've not really seen, except you tell me, I've not really seen a system where
Sir, I think there is a system, sir, because I rate with TELUS International. I rate Google. We do Google rating.
okay.
And it's equally part of the criteria that you must be a US based before you do that kind of job.
Yeah.
So if an account is being created over there and given to you, then you now have to look for a specific proxy that is covering that very location before you can work. Now,
Exactly
the
now.
question
Okay.
he's asking is, how do people still find out even though you are using paid VPN? Just like you said now, if I've collected a job that I'm working from Nigeria,
Okay.
and suddenly you see my IP address showing US,
Yeah.
and it happened that day, you give a benefit of doubt that maybe it's a glitch of network of a thing, you refresh and refresh, it's still showing that US. You leave it, the second day you come again, another time again, you are not seeing. You as a human, someone that gives somebody a job, you will know that yes, this person is using VPN, that the person's location cannot just be changed that way. So
Yes,
this is one
no,
of the way they do get to find out.
yes, that's just the thing, because one thing about infrastructure you must understand is infrastructure, in as much as it tries to be 100%, infrastructure is hardly 100%. So whether you're using paid VPN, you just have to ensure that it works when you want it to work. So sometimes sometimes your IP address, because this one you are renting these IP addresses, when you buy the stuff. So sometimes if you're not using a proper infrastructure, sometimes IP address can just change. And if you're working in an organization where they track these things very, very closely, they may flag it, you get, because if the most times the server that you're using to connect to the IP address today may be different, depending on the VPN setup you're using. So that's all the small loopholes is how they used to catch. But if you're using a strong VPN, I've not really seen a situation where you're using a solid VPN that
Sir,
you will be caught.
sir, if you are using a solid VPN, how about your network, sir? If once your network glitches, there is boundaries that you'll be exposed, sir.
Yeah, exactly. That's also another problem as well. I've not experienced it before, so that's why I can't really answer. But if there's a possibility of that happening. There's a possibility of that happening. So yeah. Have we answered your question, the Jose Mario? Oh, okay. It's probably the system, the network, your network and the system that they have set up, basically. That's all it is. The most of these foreign sites, they're always adapting. So the more we find ways, to get into their system, the more they find ways to block us. So that's just that's just it. Personally, most of the time, I use Tailscale. So Tailscale, they have like a VP. I don't know if you're trying to access network. So what I do with VPN is I don't use to access sites and all those, websites. I use VPNs to access networks. So if I want to access a network that is only, for example, I want to work on a server now. Sometimes I can be in Nigeria and I'll get probably a gig that I'll need to work on a server in like US or UK or somewhere else. But their server are only restricted access from within that location. That's what I use VPNs for. You get, so I will connect to the VPN, to a VPN using I use Tailscale. I connect to Tailscale and I'm able to the whole setup, I'm able to access that server and to do whatever I want to do on it. Because with my normal laptop, I won't be able to do it. So that's basically what I use VPNs for. Except the normal, using VPNs for Twitter and that's when it was banned by the. So yes, is there any more question, please? So if there are no questions, I've noticed only 11. Yeah, exactly. That's also used. That's also what's the logic behind that. So, like I said, this whole, like I said, this kind of setup now we use stuff like Tailscale. Now, what Tailscale does is that you install Tailscale. The person over there will install Tailscale on their laptop. Once they install Tailscale on their laptop, they will create like a secure network over the internet. You get. So that secure network now, they will now invite you. I don't know. This is like a rough logic. It's not as if it's something that's set on stone. So based on my experience, when they set up that secure network, you get, they will now invite you to authenticate to their network with your own IP address, your laptop IP address. So once they create that, so their system now, Tailscale will use their system to create like a network with their IP address on their system. So you now will now connect to that network. That's what Tailscale does. You connect to that network, you create an account, you connect to the network. Now, from your laptop, you can be able to access the IP address of that person's laptop. That's how it works. That's why if you want to, the IP address that you'll be given to access the person's computer, that your friend was given to access the person's computer, if I put that IP address on another computer, it will not work. Because your laptop now is authenticated with the IP address of that person's computer using Tailscale. So it's Tailscale that we use mostly to do this stuff that we do. So that's just it. I don't know the underlying infrastructure behind Tailscale, but that's just what I'm giving you on a rough. Tailscale is, I have not set up Tailscale before. It's usually the people that you are working with that set up Tailscale. But I think it's paid. I think they pay
That
for it
is
for
paid,
something that's,
sir. It's paid, sir.
yeah,
Something like
for something
something
that's,
similar to it is Proxifier. That
yes,
Proxifier, it clones, it's an invitation to clone your system. That very
yes.
device you are
So I think,
sending.
yeah, I
Once
think Tailscale is paid. Tailscale is paid because, yeah, they will invite you. Once they invite you, you authenticate, which is like you authenticate with your IP address, so you can connect from your laptop to the person's laptop. It's like it's all in the internet. The whole networking is on, but it's secure. So yeah, that's it. Yeah, no, that's when I want to try it out. Okay, oh, no problem. So does anyone have any questions so far? This class is, okay, let me stop. Okay, like I said, today is I don't know, the class is so quiet. Are you sure people don't have any question? There's some people that I'm expecting to
sir,
submit their tax.
sir, we have questions, but it's
Eh,
not regarding networking. I don't know.
what is it regarding?
So it's introduction to Linux and Linux fundamentals. Like
Okay.
I'm part of those people you are expecting our